Hi everyone. All right, for today's lesson, I know I'm not here, but we are still going to be talking about physics. So, we start with a warm-up. Don't worry, you don't have to write this one down, but I do want to talk about it. This warm-up says, what happens if Mr. Engling sits on a chair with wheels and he pushes against a wall with his legs real hard? What would happen? Here's a picture of Batman doing that same thing. He's on a wheelchair here, and then he pushes against the wall. And then something happens. We're going to come back to this question at the end of today's notes, but this is something I want you thinking about while we're discussing the notes today. So, today we're covering the third and final law of motion. The third law of motion, Newton's third law. This law says for every action there's an equal and opposite reaction. When you push on something, that something pushes back on you. So, for example, things like a cannon. When the ball pushes this cannon backward, it also pushes the ball or the cannonball forward. So whenever something gets pushed, it's really pushing back on something. And that brings us to this important point that forces happen in pairs. These pairs are called Newton pairs. And there's always a force and a reacting force. And I think one of the best ways to understand this law is to look at examples. So I've queued up a video for us to watch. And let me turn up the volume so you guys can hear it. This video is going to talk about the third law of motion in space. So let's take a look.
Welcome to the International Space Station. I'm NASA astronaut Mark Vande Hei. Today, we're going to talk about Newton's third law. How do you think it will hold up in microgravity?
For every action, there is an equal and opposite reaction. This means that in every interaction between two objects, there are a pair of opposite forces acting on each object at the same time.
So yeah, that's the official law, what it officially says, right? But the important thing to remember here is for every action, there's an opposite reaction. For every force, there's an equal and opposite force.
Right. A force pair. You can see that there are many examples on Earth. In space, thrusters expel one way and the vehicle is steered in the opposite way.
Hello again. More basketball stunts that I can't do on the ground, at least not while getting this much hang time. All right, back to serious business. Got a basketball right here. It's going to be object 1. I'm the second object. If object 2, myself, applies a force to object 1, then that same force will be applied according to Newton's third law by object 1 onto object 2. However, there's a big disparity in the mass. Object 1 is a very light mass object. Object 2, myself, is a larger mass object. So, I'm going to try to make myself about the same shape as this ball. See how that works for us. And I'm going to apply that force.
So what we saw there, remember Newton's third law. For every force, there's an opposite force, a force pushing against. The ball is being pushed away by this astronaut, and as the ball is pushing away, that ball pushes back on the astronaut. Now here's the thing. The ball is not very heavy, and the astronaut is. The astronaut is a lot heavier. Therefore, the basketball is not going to push him as much as he pushes the basketball.
You saw that force applied to the ball made it accelerate quite a bit. It really didn't accelerate me much at all. Newton's third law again, but this time we're going to use two similarly massed objects. Joe and I have about the same mass, so Joe, get into a ball. I'll do the same. I'm going to face you this way so I don't throw you into something you can't see. Now I'm going to get into a ball behind Joe, and I'm going to apply a force to him.
Alright, so before he applies that force, this time we have two objects, in this case, two astronauts, and they are of similar mass, meaning they weigh about the same. There's the same amount of weight for both of them. Now, if he applies a force on this other astronaut, that astronaut is going to push back on him a little bit. Because remember, Newton's third law says for every action, there's an equal and opposite reaction. For his push, there's going to be an equal push backwards. Let's see what happens. Look at those arrows here. Here's the force he pushed the other astronaut forward with, and this is the force that this astronaut was pushed backwards with. They're equal. He pushed the astronaut forward, and the astronaut's body pushed him back with an equal amount of force.
Notice that when I applied a force to Joe, it accelerated Joe away from me, but I got accelerated away from him as well, because the force applied to Joe ended up being the same force that was applied to me. Now you've seen Newton's third law in space. Now test it out on Earth.
All right, we don't need to watch the rest of this, but let's go back to our notes. So we got one more slide to write down, and that is our example slide. So you guys watched an example of the third law in space, but there's lots of examples of the third law of motion happening right here on Earth. One example is something you guys do every day while you're walking to class. Just the act of walking is a great example of the third law of motion. As you push on the grass with your feet, the earth and the grass are pushing back on you. That allows you to step forward. You're not sinking into the ground in that case. The earth is pushing you forward. So as you are stepping down, the earth is pushing back up with an equal amount of force. Yeah. All right, you guys. These are our notes for today. Excuse me. These are your notes for today. The next thing you'll do is you're going to do a little bit of reading. Make sure to answer the questions when it comes to the reading as well. And make sure period 3, make sure you turn in your homework. If you're not period 3, don't worry about it. Everyone else, all right, you guys, enjoy the rest of your day, and I'll see you tomorrow. Bye.